Hi folks, I'm Michael Freiert, and due to the glories of technology, you're getting a re-recording of this while I'm on a friend's boat in rural northern Minnesota. My apologies for any wind noise. I think I've got it set up so I shouldn't get too bad. It's being recorded because I wasn't able to make it in person this year, and aside from missing all the other great presentations in person, what I'll miss the most is those individual conversations on the side between sessions. And those conversations are often as thought-provoking as the presentation, so please talk to the folks sitting around you after this session. So what am I going to talk about? It's sort of just simply measurement, but it's also about the idea of how we quantify abstract ideas and convert them into digital bits and bobs that a computer can understand and talk about. It might seem like I'm going to ramble a bit, but I promise it'll all come together. The idea for this talk started over a decade ago indirectly. There was a forum post about room phasing in Revit and how it wasn't working how folks wanted. Like so many problems in BIM workflows, the problem folks were describing was not actually a problem with what the tool was doing, but the difference between what the folks' expectations of the tool was versus what it was designed to do, and the practical limitations of computational logic versus the mess of reality. Measurement is complicated. It's its own rabbit hole of engineering, and I'm not going to stray too far into it, but suffice it to say that I've wandered down the rabbit hole a little bit. I do some hobby machining, and I know that the cheap surface plate that I have in my garage is not something that a professional would even take home from the trash bin at work. But I understand that it's more than flat enough for my uses with my small hobby metal lathe. Yes, I can get parts accurate to less than 1/1000th of an inch if I need to, but let's not kid ourselves. I don't really need to. I'm sure you're all familiar with my favorite unit of measurement, though, the barley corn. I'm kidding. Some of you are probably familiar with it. It's an awesome imperial unit, but for the sake of this conversation, let's try to talk mostly in metric. For everyone listening in the US, when I say centimeters or millimeters, just pretend I'm talking vaguely in quarters or 30 seconds of an inch. And now that I've reduced any metrologists watching to complete apoplexy, and they won't get a bit more upset by my butchery of let's define two terms: accuracy and precision. Accuracy is how close a measurement is to reality. It's a specific value. And precision is how close we can get to accurate more than once. You can think about it like the bullseye of a dartboard is accurately the center. You being able to hit where your last dart went, again, is precision. You being able to hit the bullseye every time is precise and accurate. Now we all know what a centimeter is. But what do we really mean by it in various usage? If I say that I'm 176 centimeters tall, that will make sense to almost everyone here intellectually, and is good enough for my medical chart or driver's license. But if you took a 3D scan of me with a reasonably modern laser scanner, you'd get a different measurement in height in the morning versus in the evening, and if you plug that into a computer, you're going to have to pick one to model a rendering asset of me in Enscape for whatever foolish reason. Well, suddenly, on the computer, I'm numerically precisely that tall. Not a millimeter more, not a millimeter less. That asset is always precisely that tall. But that's not an entirely accurate representation of my height at any given time or any given day. It's accurate to the measurement tool's level of accuracy when the scan was taken. And while I vary a bit in height based on things like which shoes I'm wearing or if I'm slouching, you will all recognize me as me. But that computer model of me will always be precisely that height, which may not accurately be how tall I am right now. So where the doctor's office is probably considering my height to be accurate enough within half a centimeter, that computerized number is mathematically precisely always that number, and it won't change. There's no it's accurate to within 3 millimeters that you might get with a good point cloud scan of a building. It is exactly and precisely that number. There's no variance. The digital bits of that number are what they are. This becomes a twofold problem with BIM. First, how do we intellectually remove the fuzz of the real world? And second, how do we deal with creating precise things that are representing something that's inherently imprecise? Well, the second part's pretty easy. We just use level of design, right? LOD, or level of detail, however you want to phrase it. Whatever level of that is, we're going to do, we just model it to that point and call it good enough. Except that it's not. Something that I've noticed more and more over the last decade is that when something is not intentionally designed as a generic element to begin with, whatever that wall assembly or finish or whatever was picked to start with as the initial piece out of the template, it will stick with it all the way to project completion. Now, most of the time that's great. The firm prototype starts out with a very typical construction, and that never needs to get touched again. You don't have to rehandle information. But occasionally that initial item just stuck around because no one bothered to worry about it again. Not because it was the correct item, or even correct enough, but because there was no questioning of what that particular item was doing throughout the remaining process. Conceptually it was there, but its initial definition was never re-examined. There's no way for a project team that includes multiple designers and a moving cadre of various staff to hand information about each and every object and what it was supposed to be, other than maybe an LOD 100 placeholder for something someone else was supposed to refine later. Maybe they did, maybe they didn't refine it later. Okay, so suddenly it's a little bit messy. Let's talk about the first bit. Maybe that's easier. We want to remove the fuzz of the real world. Remember that granite surface plate in my garage? It's flat enough for me, but not really flat for a metrologist. It's probably orders of magnitude flatter than any gypsum wallboard wall ever built. But if we represent even that vaguely flat surface plate digitally, the reasonable option is to call it a flat plane. But we could also build a digital mesh that is accurate to the 10,000ths of an inch at many points across the plate. There are measurement tools that do just that. So how accurately do we need to represent reality in our digital models? Well, that's a really messy question. I had a conversation about point cloud scanning with a now retired senior architect about the precision of digital measurement. I confidently stated that the digital measurement was well under 1/4 of an inch, about 6 millimeters, and they also very confidently informed me that that was nowhere near close enough, and we drafted everything to the 64th of an inch, under 1/2 millimeter. Now, while it's true that we rounded our dimensions in Revit and AutoCAD to the whole millimeter, just to make it simple, we didn't actually really expect the builders to be building to sub-millimeter tolerances. We knew full well that the corner beads and mud over the screws and the drywall were going to be at least 3 millimeters different from the theoretical plane of the wall than our perfect digital vector graphics that have replaced our far more elegant ruling pens that were so theoretically flat line would produce. Since the earliest inklings of the standardization of measurement in the early 1600s, but not really until the Industrial Revolution, we have understood that our documented measurements are theoretical and not necessarily exactly as we're describing them to someone else. We may say that we're building a flat wall, but any cabinet maker worth their salt is going to be scribing to fit their wood to fit your wall and not bringing a board they milled flat in the shop. Flat has always been relative from the time that architects were doing fitting of stones together on the cutting house floor. The jointed edge of a door is not the same sort of flat that a dry fit stone wall will be, but we define both of them with the same theoretical pen stroke. Those pen lines are intellectually flat to us, the flat we intended, but as with a computer representation, it really is flat. And what we've learned from 4 decades of computer-aided drafting and design is that we need to put that line exactly where we want the wall to go. If you draw your wall slightly out of axis in Revit, it'll get cranky. There's a good reason for that, but that's a whole different talk. And if you stack up errors of that computer rounding, well, you may end up with an internal design set of dimensions that doesn't fit within your overall building dimensions. So best practices have evolved to put things really at the theoretical place that tradespersons is capable of install it as. So the new theoretical fuzz we're describing is easy. We just let things fall where they will. But how about connecting to the existing? Again, this is easy. You or whoever is working with whatever theoretically perfect data the computer has for a point cloud, or hopefully competent intern with a tape measure, we know we're working with something real and that has some wiggle to it. We know that we want to add a plus or minus, or a hold or field verified note to critical dimensions. Because we as a practice still remember that the world's a little uncertain. But hang on, we can't put that a 950 gigabyte file on everyone's computer. It will slow down people who don't really need all those points. Most conversations that revolve around the data captured in the point cloud need to deal with the aggregation of those points, about the walls and the floors and the theoretical BIM objects that are amalgamations of those millions of points. If your scan to BIM subcontractor was only going to model to LOD 200 and everything's going to be flat, well, that's not how a historic building was built. That doesn't work for us. So how do we deal with that mess? An LOD 200 as-built might be close enough for schematic design, for some space planning, but it will have significant variances that will cause field coordination issues. In assessing proposals for a rather large scan-to-BIM project that we were having modeled externally, I tried to define how we wanted those things modeled. and I started off with flat surfaces should be modeled as such as if they were flat to within 1 inch across the surface. But if that surface could be modeled square, I realized that I wasn't going to capture what I wanted. That, in terms of legalese, sounds pretty good, but what I really wanted was something like this. Look at the surface and think about what's probably going to happen to it. Is it pretty flat in terms of modern construction tolerances? Then put it there. Is it enough out of whack that we may have a structural or design concern? Then model it there so that the production team can see potential problems and know to refer to the point cloud scan for more information, or to just work with what seems a little bit wonky. It's really hard for a lot of folks to accept that sort of instruction for a business contract. It requires them to think about what their work will be used for down the road that they have no control over. But that's what BIM is. We're all here because we want to see and leverage data as a trail from concept all the way through construction and ownership and eventually end of life of the building. That's why we're here talking about this idealized building that we know is somewhat abstract and we want to be increasingly perfectly accurate. But reality will never be as accurate in the real world as the numbers on the computer will be. We've got two problems: being forced to represent something that is imprecise very accurately, and being required by our tools to accurately locate something theoretical and very precisely that will never be created there. Now, we've got a third issue: tolerances. What if it really doesn't matter for the project that something hither or thither, half a centimeter out or worse? I've got a dumb, crazy idea that's remarkably easy and difficult, and very difficult at the same time to implement. Let's start looking at two theoretical parameters for our digital content. One is the concept, and the other is fuzz. What I'm calling concept harkens back to the old school Revit practice, like 2 decades back, of putting in generic content as we sketched. You placed a generic object, and later on you changed it to whatever you actually wanted it to be. And you might even go so far as to have a working schedule of items that were still generic and needed to be defined later on in your CD set. Now, as a data practice, we need something better. There's no reason to handle things more often than they need to be. But we need to be able to say that one or more objects represent an abstract idea, such as a separation between two rooms, even if that separation moves. And that needs to be accessible in multiple data streams and multiple editing tools. The concept parameter allows us to associate all of those millions of individual scan points with one wall, and then to say that the abstraction of them as a mathematically dead flat plane, and to exchange that data depending on what we want to do with it. It allows an architectural designer to plop a LOD 100 rectilinear blob on a roof and say, here's an RTU, and the mechanical engineer to take that concept and say, this is going to be this specific unit. And then an operating engineer to reference the manager's model and video associated with the last maintenance of the unit that was actually installed. We can have multiple assets with varying levels of accuracy and varying levels of information show up to different users. And someone editing one theoretical element in Inventor can produce a notification in Revit or other softwares of that overall information model change. The same concept can even track changes across time. Now, fuzz would let us recognize and quantify our inherent lack of precision as precisely as our data sets require. It sort of builds in that plus or minus dimension. It's admitting that in our theoretical model that we have not identified where something really is. But we've gotten close enough, but more importantly, how close we consider close enough to be. In specifications and codes, we explain how flat a particular surface must be and how we want it measured. We don't talk about how we're translating that into our digital models. I can see the eyes rolling now. Michael, this is silly. None of it matters. We've built buildings for centuries and made them fit. That's absolutely correct. But most of the time what we don't need to worry about is how accurate our BIM models is in its finite precision. It kind of doesn't matter. It's going to be delivered within half a centimeter or so, and that's fine. But we are already at a point where we're shipping prefabricated modular construction that is accurate to the millimeter per modular unit. And if you start stacking up that only 3 units out by plus or minus a millimeter, one side of your building got all the minuses, and suddenly you're looking at a wall that has a 5 millimeter staggered seam in the middle of it. For most of us, that's not a problem. But for the folks doing that work, it's critical. The stacked imprecision results in additional work that offsets the efficiencies that we're seeking. So remember at the beginning of this talk where I mentioned that I do some hobby metal machining? I also do gardening, and I study locks. Now if I'm making a lock for fun in the garage, certain parts need to be about as accurate as the thickness of a human hair for the lock to really work. But when I'm building a new garden bed out of some landscaping timbers, hitting within a centimeter is just fine for cutting those. Those are all parts that go into my home. Both that lock biting and where that landscaping timber go in a theoretical BIM model of my house and my yard are useful data points. If you're putting a photocopy machine into your BIM model, you are including parts that have an accuracy documented by the computer in their fabrication down to the thousandths of a millimeter. For the architectural work of BIM, and what most folks are reasonably doing with the data, we don't need that. LOD 100 is probably just fine for that copier. But ideally, the big idea of BIM is that someone is going to want to know what that model copier is and what the specs of the pulley inside of that one misfeeding thing are, and whether they can order another, or what they can manufacture another because it's out of production. We need a way to communicate what those pieces are and what they are associated with. Now, it looks like some platforms are finally starting to look at tying objects together across software formats, but I've not seen anything really recognizing that different data points are representing the same idea. And how do they differ from the computational accuracy to the theoretical real-world position? That Revit room discussion that I mentioned at the beginning, it was and is a disconnect between how we as humans philosophically describe a room and how a computer needs to specifically quantify that. With a computer, we have infinite accuracy, but that's not how we as humans think. We don't work in perfect surfaces or of infinite accuracy and precision. We work in close enough. And we're hitting a point in BIM that we need to be able to explain what each of the folks touching the model need to know about an object. Recognizing that your model as it stands today will always be inaccurate, and your needs for accuracy will be different from other users of that model. We need to find a way to facilitate other users' needs while still not bogging ourselves down. Thanks. If you want to talk more outside the roundtable, please reach out. I'll be missing those side conversations in Dublin with all of you. If you got something you'd like to chat about, whether positive or negative feedback, probably not boat wind noise, not much I can do about that, but any insights you want to share with me or just something fun, I would love to hear it, and I am missing seeing all of your smiling faces in person.